Alright, vintage computer fans, here's one more RetroChallenge 2023-10 update. When I entered the competition, right, the challenge, I promised that I would implement a real-time clock, a battery backed up real-time clock for the Microtronic for my PicoRAM 2090 project. And by now I've connected this very popular DS3231 battery backed up real-time clock module, right? It's an I2C module. So it's part of my hardware setup, and I've implemented the firmware for it. So the Microtronic has that real-time clock access by now. Let me demonstrate this. So let's power up the Microtronic.
Microtronic talker initialized.
And so the Pico can access the real-time clock directly, right? For example, it can print the current time on the display. There you see it, quickly showing up here. So it's 9:29. Also hooked it up in such a way that it can speak the time.
It is 9 hours, 29 minutes and 18 seconds. It is 9 hours, 29 minutes and 22 seconds.
There's also a program that then allows you to set the time, right? So can't set it for now, but you can change the time with the cursor keys here, basically, right? And go to the different positions. And okay, I haven't changed it now, but I can save it.
It is 9 hours, 29 minutes and 37 seconds.
So the changed time has been saved to the real-time clock now. And that's all good and well, but how does the Microtronic actually benefit from that, right? Adding a real-time clock, I mean, it's nice as a speaking clock, or just to have a clock basically in the Pico, but obviously the real benefit is that the Microtronic can then get to know the real time, right? And so the Microtronic already has an opcode in its instruction set that allows it to load the time, right? So the Microtronic has its own clock program in the firmware, but it's not battery powered, right? So what we do here is we intercept the load clock opcode, right? And using the banked memory trick, we then get the real-time clock time basically and inject this into the Microtronic, into the registers, which would usually be written by the internal get clock opcode. And I've already set up the memory banks in such a way that if you power it up, the PicoRAM and the Microtronic tandem, then you get a program that does exactly that. So the time is stored in registers A to F. So we are displaying the registers A to F here on the display, F6A. So that means in A and B we have the hours, then we have the minutes and the seconds, right? So let's see. And then here is the F06 opcode, which loads basically the time, usually from the Microtronic internal clock, right? Which is not battery backed up, so it's not a battery backed up real-time clock, but I implemented this opcode now in such a way that the Pico intercepts this, and as I said, it will then fetch the real-time clock instead values and put that into the registers, right? And then we just wait for a key press and we start the program over. So by executing this now, let me arm basically the opcode extensions here and start the program. We can now see that the Microtronic has loaded, using the Pico and the real-time clock, the actual time, right? So it's 9 hours, 9 o'clock, 31 minutes, 57 in the morning. If I push a button, it updates the time. A few seconds have passed, 12 seconds, 16 seconds, and so on. And note that this coincides is the same time, of course, that the Pico would also.
It is 9 hours, 32 minutes and 26 seconds.
26 by now, 30 by now. Takes a few seconds to load this from the real-time clock into the Microtronic. Yeah, so that's implemented, and just to show you that it's really a working real-time clock, let me change the time to say 8 o'clock and 32 minutes.
It is 8 hours, 32 minutes and 38 seconds.
Now the display is also being updated, right? This program, which actually loads the real-time clock into the Microtronic, is written dynamically based on the current clock time, real-time clock time. And let me also show you that it's really battery backed up, right? So I'm turning it off again. And let's see if we can get the time back. So we set it to 8:30 something, right? Let's just execute the clock, real-time clock load program. And you see there it is, 8:31, 33 minutes and 19 seconds.
It is 8 hours, 33 minutes and 38 seconds.
Okay guys, that's it for now. So there will be one more update where I wrap it all up. But so far, by now I have a feature complete RetroChallenge contribution, RetroChallenge 2023-10. That's all I promised to do, and so I think all I have left to do is basically one more final demo video in which I show all the capabilities that I've implemented for this project. Alright, thanks for watching, and I hope you continue to enjoy the RetroChallenge. Bye.